2 completely between subjects ANOVA, factorial, complex ANOVA. I'm just calling it 2 by 2 between to keep this simple. You want to know 3 things. You want to test 2 main effects in an interaction. You have 3 nulls. For a 2 by 2, your null for main effect 1 is that your mean difference is 0. There's only 2 means. So it's not 3 means. There's only 2 means. So that's your null hypothesis. Same thing for main effect 2. Only 2 means. There's your null hypothesis. Your null hypothesis for the interaction is that the population slopes are the same. We talked about that in class. I'm not going to get into it in this video. I don't want this video to take too long. We still have our effect size is a 95% confidence interval. Or I'm sorry, is eta squared, and it means the same thing. Also, however, I do want to point out that with this test as well, for the main effects, you get to use Cohen's d. So you can choose to use Cohen's d and 95% confidence interval of Cohen's d. In fact, I think this is the better method. F still tells you the same thing. Now, your data will look like this. What you have is a participant column. You have one column for independent variable 1's conditions, one column for independent variable 2's conditions, one column for your dependent variable. So right here, participant A, they were in the anger condition. They're a young adult. They're younger than 25, and their political aggression was 5. Right? Let's choose another one. Participant D, they were in the happiness condition. They're a young adult. Political aggression 1. Participant G, they're in the anger condition. Old adult like me. Political aggression 3. Right? So the main like trick you can use to figure out if you have a completely between subjects design is if you're only recording your independent variable once from each participant, you're only recording their political aggression once from each participant, then you have a completely between subjects design. Entering your data should be old hat by now. 1 row per participant, right? This participant, they were in the anger condition, so 1 column for IV1, 1 column for IV2, just identifying which conditions they were in. This person's in the anger young adult cell. Their aggression was 5. Anger young adult cell 5. Anger young adult cell 4. Happiness young adult cell 1. The happiness young adult cell 2, so forth. 1 row per participant. That's always the rule. 1 row per participant. So now we want to run our ANOVA. We click ANOVA, ANOVA. I've been playing around with this, so it shows me everything open here. So my dependent variable is aggression. My fixed factors are emotion and age. My effect size is right here. I'm going to do this in steps, going through each box and showing you what happens. Okay? So here, just the basic test, you're looking at this. What am I looking for? Well, first I'm testing the main effect of emotion, the main effect of age, and the interaction of emotion by age. These are my 3 effects. I like to do them one at a time. Let's do the main effect of emotion by itself. We have a significant main effect of emotion. I don't know anything about the direction of that effect because I haven't asked for that yet. Okay? It is significant and the eta squared is rather large. So I want to explore this emotion main effect. And this is how I do it. I take my time. Yes, I notice the whole pattern, the significance pattern. I see that. I see I have a significant interaction and not a significant main effect of age. But we're going to ignore that right now and just focus on emotion. All right? So now what else do I need to know? For me, I want to go into the post hoc tests, and I want to know, like I said earlier, you can get a 95% confidence interval of Cohen's d for this main effect. I want to know that. I still don't know what direction, but I can tell that anger minus happiness was a positive mean difference. So anger had more political aggression than happiness. I could see that from the mean difference. Ultimately, the post hoc tests, right, you have different corrections. You can have no correction, Tukey, Bonferroni, doesn't really matter to me. We talked about when to use them, but I'm not going to talk about that today. Sorry, got to click it over for us to see. Ultimately, I don't care about these p-values. None of this really matters for me. All I want is this Cohen's d and 95% confidence interval of Cohen's d. Okay, so my Cohen's d is large. My lower level is less than small. My upper level is large. We know what that means by now. So when I'm reporting this, right, when I'm actually reporting this, I write my main effective emotion was significant. You can write that, right? And then you write F, parentheses, 1 degree of freedom, comma, 8 degree of freedom, degree of freedom of the effect, degrees of freedom of the error term. That equals 10, comma, p-value, 0.013, comma, Cohen's d equals 1.826, square bracket, 0.129, comma, 3.523. You can go ahead and put the eta squared in there if you want. You can get the 90% confidence interval of eta squared, but honestly, that'll just confuse your readers. This tells me very clearly you have a large effect in your sample that in the population could be less than small to large. I should run a larger sample size. I know that. You will not get non-parametric tests for these ANOVAs. You're just going to have to let that go. It is good practice to check those non-parametric tests and check for violations, but we're going to let that go because we're doing so much right now. So we got that Cohen's d result. I didn't need to do post hoc tests because I only had 2 means, but I wanted that 95% confidence interval of Cohen's d. The other thing I would like is just marginal means tables and plots. So that's going to help me out quite a bit. Right here I can see I was right. My anger manipulation led to more political aggression than my happiness manipulation. Awesome. These are going to come in handy when you want to make that main effects graph. See the handout, C Lab. They're going to teach you how to do that. All right. So that's main effective emotion. Now, I got everything clicked that I want. I keep clicking in here, and I apologize for that. I want to do main effective age. So I'm just going to make my life easy. I do not like the massive outputs that I get all the time from Jamovi. So here, I did that backwards. So I'm going to take emotion out of my post hoc test. I'm going to put age in. Earlier I clicked these. I didn't have to click any of those. It doesn't even matter. What I want here, the only thing I want is I want my 95% confidence interval, my D, and my 95% confidence interval of Cohen's d for the main effect of age. So now we look at this. The main effect of age was non-significant. F, parentheses 1, 8, parentheses, end it, equals 0.40, like 0.40, comma, p-value equals 0.54. Cohen's d equals 0.365, 95% confidence interval of Cohen's d equals negative 0.983 to positive 1.71, negative large to positive large. We know nothing. We can tell that right now. The other thing, I just want to make sure I'm getting my estimated marginal means for age. Remember I said I did that earlier. You can see when I did that, but I flipped them out and I have young adult, my means and standard errors. So those are my 2 main effects, and I just described how you'd write them up. Both of these have 2 levels. I get the Cohen's d because it's between subjects. Super easy, super simple. I'm going to go ahead and use those Cohen's d's instead of eta squareds. And you can see why. A 2 mean comparison, Cohen's d is the best effect size. We are good and ready to go. Now the interaction is our next issue. Dr. D suggests we do not get post hocs for the interaction when it's a 2x2. And I am just going to show you why. So I took the post hocs out just to make our output a little bit more sensical. They might teach you to do mean comparisons in the lab. You can do what they tell you in the lab, but I'm going to sort of show you my thinking here. So what I'm going to do is put emotion and age in together as a term. I'm actually going to add another term. I'm putting age in first and then emotion in there. I'm going to show you something. because you play with your data when it's this complicated. You gotta look at things. All right. So I know I have a significant interaction. I do not know the nature. I know an interaction is just testing if this slope is significantly different from this slope. I have two pictures because there's two ways you can draw this, right? A motion on the x-axis, age on the x-axis, okay? Now, when I want to describe this interaction, you can use Dr. Miller's but analysis. For young people, the anger manipulation increased political aggression in comparison to the happiness manipulation. But for older people, the manipulation had no impact on their political aggression. I take that out to the next step, right? What am I going to conclude in my conclusion? I'm going to say, look, old people have a level of political aggression that can't really be messed with. We are old. We've been around. We're angry or we're not, and that's where it is. It's not impacted by manipulations like young people's would be. I can see that in this graph right here. That makes sense. I understand that interaction. I can describe that to anybody. Basically, for adults, the manipulation had no impact. For young adults, the manipulation and the impact we expected were anger, increased political aggression in comparison to the happiness manipulation. Now, the other way you present it, it's like, okay, for when anger was manipulated, adults had less political aggression than youngsters. When happiness was manipulated, adults had more aggression than youngsters. Both of those are fine interpretations of your interaction. It's just whichever one resonates with you better. I really think this one makes the most sense out of the two. These are just your cell means and so forth. Now, if you are asked, now you will be asked to do some mean comparisons. If you made predictions and you want to compare like all sorts of means, you can run your post hoc test and choose your correction, right? If they're predicted no correction, most of us will use Tukey. You were taught Bonferroni. Bonferroni's like the worst. I wouldn't use it. Holmes really good too. It doesn't really matter, okay? But essentially, this right here is an anger person, young adult anger versus adult anger. The mean difference was 2, right? Is this significant? No, not with correction. Yes, if you previously predicted it. 95% confidence interval. It's all the same stuff, but you can get all your mean comparisons here. This one right here is angry adult for happiness young adult, like if you want to make those comparisons. With this table, and I should really show it a little bit better. With this table, if you're doing these comparisons, you're really going outside of the interaction if you don't only test the line. So this is my favorite interaction graph. I should test young people anger, young people happiness. So young people anger, okay, got that. Young people happiness, that result is significant and it is a large effect, okay? That's this one. This one right here, old people anger, old people adult, old people anger, old people happy. So these are the old people anger versus old people happy. This result is non-significant. And our 95% confidence interval tells us we don't really have a handle on like this effect, right? Like if you don't look at this 95% confidence interval, oh, you're like, there's no effect. There's no effect in the population. In fact, when we look at this, we're like, oh shit, I don't know anything. I don't know anything right now. So that's where it is. Okay, but those are the only two comparisons I would do to test this interaction out. Other comparisons are going to mix main effects and interactions, but this is how you read that table. Now, we're not done yet. To report this interaction, we do not have an effect size yet. So, we'll talk about that. There was a significant emotion by age interaction, right? I have to describe this pattern of the interaction, which I've already done, You're eventually going to have to describe that. But there's a significant emotion by age interaction. The F with 1 in 8 degrees of freedom equals 10, right? So F parentheses 1 comma 8 equals 10.00, comma P equals 0.013, comma eta squared equals 0.352. And now we need the 90% confidence interval of eta squared, and we're going to need that. We're going to use the between subjects calculator from our website. So all I have to do here is click on our website. I'm going to click back one more just so you can see it. Between subjects. This is a between subjects interaction. Okay? It doesn't involve any within subjects. It involves between subjects. So I click the between subjects interaction stat. What do I need? I need my F statistic. I need degrees of freedom 1, degrees of freedom 2, and my N. My sample size is 12. Okay? And I go back. My F statistic was 10. My degrees of freedom are 1 in 8. So 10, 1, comma 8. Run my 90% confidence interval. Don't know why it hung up there, but now we're good. The lower limit is 0.07. That's good. That's a nice medium effect size, 7.6%. The upper limit is 69%. So the population effect is somewhere between a medium and large effect. But I write my eta squared, which was like 0.3 whatever. We'll go back to it. My eta squared is 0.352. And my lower limit was 7, and my upper limit was, I believe it was at 69-ish%. So I know that this interaction in the population is between a medium and large effect. Okay? I would choose for these between subjects 2x2, these 2-level IVs, I'd use the Cohen's d that it gives me down here in the post-hoc test. That is everything. It's a lot. We did 3 effects in 15 minutes. This is a lot.